All right, IM1 classes. Today we're talking all about linear functions. We already know what functions are. We did that last unit. And so now we're going to talk about what makes a function a linear function. So what is a linear function? Simply, it's a function that when graphed makes a straight line. That's all it is. So if you think about that word linear, it means to make a line. So here is an example of a linear function, straight line. Here's an example of a function, but not linear because it's not a straight line. It's that simple. When you're looking at graphs, it's super easy, but sometimes we're not always going to be looking at graphs to determine if something's linear or not. We might just be looking at the points in the table. So a function is linear if the x and y values in a table both change at a constant rate. So couple of examples here of linear and not linear. So here, this is linear. So if you look at the x values are increasing by 4 each time. All right, the pattern is to increase by 4. Then if you look at the y values, the pattern is increasing by 3. And since the x values are increasing by a constant rate and the y values are increasing at a constant rate, that makes it linear. So here on this one, the x values are increasing by 1 each time. So plus 1, plus 1, plus 1. You can do a different color for the y values. The y values are increasing by 4 each time. So plus 4, plus 4, plus 4. That makes it linear. So here, we look over at this. The x values increase by 1 each time. So plus 1, plus 1, plus 1. But then look at the y values. They are not increasing at a constant rate. So the y is plus 3 here, but then it goes to plus 5, and then it's plus 7. So there's a pattern of how it increases, but the numbers need to be the same. So this is the issue here. These are not the same, so not linear. So one more example of linear and not linear, or excuse me, not linear here. These increase at the same each time. It's plus 1, plus 1, or excuse me, it's not plus 1, it's plus 2. Plus 2, plus 2, plus 2. And then if you look over here, minus 4, it's okay if it decreases, doesn't have to increase each time. Minus 4, but this one here is different. Minus 5. Since that's minus 5, that makes that not linear. So these are all the same. These are not, so not linear. So let's look at a few examples. Is the table showing a representing a linear function? So -1, so -1, 0, 1, 2. So the pattern here, they all increase by 1. So plus 1, plus 1, plus 1. On the y side, it increases by, goes plus 2, 0, plus 2. And this one down here is different. It's plus 3. So not linear. Another example. So here, increases plus 1, plus 1, plus 1. Down on the bottom, the y values is plus 10, plus 10, plus 10. Both increasing by the same amount each time. So this is linear. This is a linear function. All right, we're going to skip ahead a little bit. So linear equations. So if you're just looking at the linear equations, they will not have these things. Exponents in the exponents, x is in the bottom of a fraction, or the product of two variables. Let's actually talk about the non-linear stuff first. First one, this one's not linear because here, as an exponent. So not linear. This one here, the x is in the bottom. So not linear. And then this last one, this is the problem. This is the product of two variables. So when we see these things, again, exponents, x is in the bottom, or the product of two variables, that tells us it's not linear. So all these over here are linear. These are actually the most common examples of linear functions that we are going to be dealing with a lot this school year. These are three common. This is called slope-intercept form. This one is standard form. This is point-slope form. These are all linear. One thing I want to point out, a linear function can have fractions. So this has a fraction. This is fine. The x is not in the bottom of the fraction. That's when it can't be linear. So fractions are okay, but if there's an x in the bottom of it, not okay. So these are all linear. So let's look at an example. Determine if the equation is linear. If it is, graph the function. If we're going to graph it, we're going to use the domain 0, 1, 2, just to keep it simple. Right off the bat, exponent. Since it has an exponent, not linear, we don't need to graph it. All right. Next one, determine if the equation is linear. If it is, graph the function. So are there any exponents? No. Is there an x in the bottom of a fraction? No. Is there a product like of two variables, like an x times y? No. So yes, this is linear. All right. And so we are going to graph it using this domain just like we did in the last unit when we were graphing functions. So I'm going to take my x value, starting off with x equals 0. And the function is y is equal to 3 times x minus 1. And the 0 is going to go in for x. So it's going to be 3 times x, and again, x is 0. So 3 times 0 is 0, minus 1 is negative 1. So from there, I get the point 0, negative 1. I'm going to plot the point, 0, negative 1. I do the same thing for x equals 1. So with the function y is equal to y is equal to 3 times x minus 1. I'm going to put the 1 in for the x. So it's going to be 3 times x minus 1, and x for this one is 1. 3 times 1 is 3, minus 1 is 2. So I'm going to plot the point, 1, 2. So that's 1 on the x, 2 on the y, put a point. And then I need to do that one last time for x equals 2. So it's going to be y is equal to 3 times x minus 1, and the 2 is going in for x. So 3 times 2 is 6, minus 1. 6 minus 1 is 5. So I get x is 2, y is 5. So 2 on the x, 5 on the y. Put a point. We're just plotting the points, so that's all we need to do. Notice that all 3 points line up in a straight line. You don't need to connect them with a line yet. We're not at that point yet. We are going to do that eventually with these graphs. But right now, just plotting the points. All right. Determine if the equation is linear. If it is, graph the function. So we're going to use the domain 0, 1, 2. If it is a linear function. So again, what we want to look for, are there exponents? No. Are there x's in the bottom of a fraction? No. Are there any products of two variables? So an x times y? No. So this is linear. So we have to graph it. So this is going to be a little bit different for graphing it because it's not, we can just use a table and put in the x value, the 0, 1, 2 and the x, and then solve for y. That's fine. What I'm going to do, so we don't have to keep solving for y over and over again each time we work this out, I'm going to solve for y first. All right, just like what we did yesterday. or in the last lesson, I'm going to get y by itself on the left side of the equation. So first thing I'm going to do is eliminate the 4x from that side. So I'm going to subtract 4x. So positive 4x minus 4x cancels out. I get 2y is equal to 8 minus 4x. You can write as 8 minus 4x. We need to get used to seeing that as negative 4x plus 8. So that's how I'm going to write it. And then I'm going to eliminate the 2 by dividing everything by 2. Divide everything. So the 2's cancel out. I meant to cross that out in red. So the 2's cancel out, and I get y is equal to negative 4 divided by 2 is negative 2, plus 8 divided by 2 is 4. So here is the function that I'm graphing. I'm going to streamline my work a little bit. I'm going to use a table this time. You can do either method. You can just put your work wherever you want, or you can use a table like what I'm about to do. Either way is fine. You're doing the same thing each time. So use the domain 0, 1, 2. So first, it's going to be using the function, so it's going to be negative 2 times x plus 4, negative 2 times x, or x is 0 for this one. Negative 2 times 0 is 0 plus 4 is 4. I'm going to move this over a little bit so I don't need that much space. So when x is 2, y is 4. So I'm going to plot the point, x is 0, y is 4. So 0 on the x, I don't move left to right, I go up 4, put a point. All right. Next, I'm going to do negative 2 times 1 plus 4. Negative 2 times 1 is negative 2, plus 4 is positive 2. So I'm going to plot the point 1, 2. So 1 on the x, 2 on the y, put a point. And then the last one is going to be negative 2 times x plus 4. And for this one, x is 2. So negative 2 times 2 is negative 4. Plus 4 is 0. So I'm going to plot the point 2, 0. Scroll back up a little bit. So 2, 0 is right here. Again, notice the points are in a straight line. So when you're doing the graphing problems on tonight's assignment, the graph should always, the line should come out, or the point should be in a straight line. You do not connect the points with a line. So that is it for right now. If you have any questions, make sure you email me. The assignment's on Edge Elastic, so get started on that. Other than that, we'll see you guys next time.